to electrical or something like that, electrical or magnetic, something like that. So the laws of electricity and magnetism play a central role in operation of many modern devices. Okay, the interatomic and intermolecular forces responsible for the formation of solids and liquids are electric in nature. I believe you already studied something related to physics. For example, everybody in our class, I assume you will be able to know that everything in the nature, okay, is made of atoms or molecules, atoms or molecules, okay? So I believe you've studied a little bit about chemistry, like how do you form all these bonds between different atoms. For example, I believe you already know that the water is a hydrogen, right? And oxygen, right? So I believe you will already know that what this two means. I assume that. If you doesn't know, it doesn't matter. Excuse me. Basically, they form certain bonds through exchanging electrons. Okay, through exchanging electrons between hydrogen and oxygen. So every matter in the world made of atom and molecule. And when you talking about molecule, they actually is attached together through exchange electrons. So basically, what I mean here is the interatomic or intermolecular forces responsible for the formation of a solid and liquid are electric in nature. Well, electricity and magnetism, there are some histories. For example, documents suggest that magnetism was observed as early as 2000 BC. If you read in the newspaper or some other textbook, I assume you would know that in the early days, Chinese, they use magnetism to guide the directions in sailing. Or in Greeks, like in the documents, like electrical and magnetic phenomena as early as 700 BC. Or even the experiments with amber and magnetite. And in the year of 600, William Gilbert showed electrification effects were not confined to just amber. The electrification effects were a general phenomenon. Or in 1785, there's Charles Coulomb. There's Charles Coulomb confirmed inverse square law form for electric force. All these people, they were contribute sort of some of the study about the electric field. Electric field. So, what else? The concept of force links the study of electromagnetism to previous study. The electromagnetic force between the charged particles is one of the fundamental forces of nature. like I said, even the bond between between the atoms to form molecules, they're through this called electromagnetic forces all the time. Okay, so I believe everybody already know there are two kinds of electric charges. One is called positive, and another one is called negative. And the negative charges are the type of possessed by electrons. Positive charges are the type possessed by protons. The charges of the same sign repel one another, and the charges with the opposite signs attract one another. So I assume you already know this concept through your high school study. Just send me some message, see if it is true that everyone in the class has some idea about positive and negative charge. I hope so. Okay, good. Very good. That's something I want to know. Okay, that's something I want to know. All right. So let me continue this. There's a famous experiment you can do by yourself, actually. Here is the rubber rod is negatively charged, and the glass rod is positive charged, and the two rods will attract. So, it's very difficult for you to find the rubber rod, but it's not. But everybody got the pen. Nowadays, the pen is made by plastic. Okay, so if you scratch the rubber or the pen on your hair, on top of your head, on the surface of hair, you just scratch it, then you will find the pen or the rubber or the plastic of the pen will be negatively charged. Okay, so you can do that sort of experiment. Anyway, the rubber rod is negative charged, a glass rod is positive charged. Then if you put them together, they actually will attract one another. They will attract one another. Okay, you can do this kind of simple experiment by yourself. It's not that difficult. Now, let's say, what else should we know? Then the rubber rod is negative charged. The second rubber rod is also negative charged. So if you made these two rods close, then the two rods will repel one another. Okay, so then electric charge is always conserved in an isolated system. Basically, this is what we really like you to remember. Like say, electric charge is always conserved in an isolated system. Basically means every charge, no matter it's an electron or it's a proton, whatever. So charge is not created in the process of rubbing two objects together. Electrification is due to a transfer of charge from one object to another. For example, here, if I go back to this experiment, basically you can rub this rubber rod with this glass rod. So one will have a negative charge, the another one will have a positive charge. And basically this charge is not created. Basically means their negative charges moved from the glass rod to the rubber rod. So you have to memorize this or bear this in mind, that electrification is due to a transfer of charge from one object to another. It's not a creation. It's not a creation of charge. It's just transfer of charge. So the conservation of electric charges, we have some other phenomena, like say a glass rod is rubbed with silk. So glass rod rubbed with the silk, and the electrons are transferred from the glass to the silk. So each electron adds a negative charge to the silk. Our equal positive charge is left on the rod. So that's the process of electrification. Okay, so and then there's a second concept. So the first one is conservation of charge, electric charge, conservation of electric charges. And the second one is called quantization, or quantization of electric charges. As we already know that the charges is not being created, it's just being transferred from one object to another object. So the electric charge Q is said to be a quantized. Q is the standard symbol used for charge as variable. Then electric charge exists as discrete packets. Basically Q, if we have an object with an electric charge of Q, the Q is kind of integer times the number of integer times the charge of electrons, of one electron. So basically it's n times the fundamental unit of a charge. So this is charge of an electron. So what's the unit? What's this fundamental unit of charge? It's 1.6 times to 10 to the negative 19th coulomb. This number has to be memorized. If you want to study, no matter electrical engineer or computer engineer or civil engineer or what any kind of engineer, so you have to memorize this fundamental unit of charge. It's 1.6 times 10 to the negative 19th coulomb. So for electron, basically the charge for electron, which is negative. So the charge is negative. So it's a negative 1.6 times to 10 to the negative 19th coulomb. And for proton, the charge is a positive, which has the same, absolute value or magnitude of electrons, but with a different sign. So it's a positive proton. And then there is a concept called a conductor. So electrical conductors are the materials in which some of the electrons are free electrons. So whenever you have a matter or you have a material which is a conductor, and then that means electrical conductors, there are some of the electrons are free electrons. The free electrons are not bound to the atoms. These atoms can move relatively freely through the material. These electrons can move relatively freely. So for the core of the atom, it will not be able to move. But for the electrons, which is able to move, right? So the examples of a good conductor include copper, aluminum, and silver. When a good conductor is charged in a small region, the charge readily distributes itself over the entire surface of the material. Okay. So what is conductor? So conductor basically means there are free electrons in the material. The free electrons are those electrons which is not bound to the atoms. Okay, so that's conductor. Then there's another idea or concept called insulator. So what's insulator? Basically, electrical insulator are the materials in which all of the electrons are bound to atoms. If all the electrons are bound to atoms, which means there's no free electrons. So these electrons cannot move relatively freely through the material. Examples of good insulators include glass, rubber, and wood. When a good insulator is charged in a small region, the charge is unable to move to another regions of the material. So that material is insulated. Now, what else? Let's say there are an idea called semiconductors. So what's well, I'm really sorry that there's no way for me to improve the volume. Well, so more, I guess I've already turned everything to maximum. Okay, I've already turned everything to maximum. There's no way for me to already maximum. I don't know what to do. Well, I guess you may increase your volume. So conductor, insulator, and then semiconductor. So what's semiconductor? The semiconductor is the electrical properties of the semiconductors are somewhere between those of insulators and the conductors. So examples of semiconductor materials include silicon, germanium. Semiconductors made from these materials are commonly used in making electronic chips. The electrical properties of semiconductors can be changed by the addition of the amount of certain atoms to the material. Which means for the semiconductors, it's not conductor, which means there's no free electrons or very, very little free electrons. Okay, and then somehow you can change the electrical properties of this semiconductor by adding some amount of atoms to the material, some other materials. You can do that. So, like, there are several ways to make electrical charges. One way is called charging by induction. So changing by induction requires no contact with the object, inducing the charge. Assume we start with a neutral metallic sphere. This is a neutral metallic sphere. So what's inside the sphere? The sphere is made by, all different kind of atoms, so which have a core of the atom, which have the electrons moving around or tied or attached to the core of the atom. So if we look at this material, basically we will say this material has no electrical charge. We'll say it's a neutral. It's a neutral sphere. Because there are equal numbers of positive and negative charges in this sphere. So the sphere has the same number of positive and negative. Then what's the induction? Induction basically is something like that. If a charged rubber rod is placed near this sphere, okay, it does not touch the sphere, just near the sphere. So the electrons in the neutral sphere are redistributed because the charges with the same sign will repel one another. So basically, we have a rod with negative charge will push the negative charge far away from the negative charge. So originally, we have this material with the same amount, the same distribution of positive charge and negative charge. Then we place a charged rubber with the negative charge. And basically, this negative charge will force those negative charge or electrons inside the sphere moving far away from this end. So after everything stabilized, what we will see here is the distribution of the charges has changed for the sphere. So basically, one region of the material will have a positive charge, and another region of the sphere will have a negative charge. Okay. If we move this negative charge, this rod away, then the negative charge will redistribute and everything will go back to original. So it will be neutral again. But I can do something like that. I can connect the sphere to the ground. Normally, we see the ground as a conductor. In our electrical and magnetism study, we will see the earth or the ground is conductor. Okay? So if we connect the far end of the sphere to the surface of the ground, then after placing the rod with negative charge, then something will happen is all the negative charge will be forced far away from this from the negative charge we placed. So basically, these negative charge will move to the ground. So the sphere is ground if it's grounded. Some electrons can leave the sphere through the ground wire. Okay. Then, if we cut the wire off, means the ground wire is removed, and then there will now be more positive charge than the negative charges in the sphere. So after we remove this rod, the positive charge has been induced in the sphere. So this is one way called charging by induction. Charging by induction. This is the induction method to produce charge. Okay. Then what we can see is the rod is moved, the electrons remaining on the sphere redistribute themselves, but the total number of negative charge will be less than the total number of positive charge. So the remaining electrons redistribute uniformly, and there is a net uniform distribution of positive charge on the sphere. So basically, when we're talking about the charge, we're always talking about the net charge. We're always talking about net charge. Net charge, okay? Now, let's go to the next slide. The charge rearrangement in insulators. So a process is very similar to induction can take place in insulator. The charges within the molecules of the material are rearranged. Okay? The proximity of the positive charges on the surface of object and the negative charges on the surface of the insulator results in an attractive force between the object and the insulator. So we have a balloon. We have a balloon. The charged balloon induced a charge separation on the surface of the wall due to realignment of charges in the molecules of the wall. Okay. Basically, what this phenomenon is, if I have a charged balloon, I place this balloon close to a wall. The wall itself normally is neutral. But since we have a positive charged balloon which is placed close to wall, then the positive charge will repel the positive charge inside the wall. So basically, we will leave a negative charge on the surface of the wall. Okay, so this is something which is very close to conductor. The difference is in a conductor. See, the sphere here is a conductor. Inside the conductor, there are free electrons. So the electrons can be moving around everywhere. But for insulator, this wall insulator, the electrons will not be able to move to anywhere. But you will be rearrange the direction for a molecule. See, for example, this is a molecule. So inside a molecule, then because of this induction from the charged balloon, then on the surface of the wall will show a negative charge. But this is not because free electrons. These electrons are not free electrons. Okay, so that's difference between inductor and insulator. So this is called the charge rearrangement in the insulator, which is similar to the induction in a conductor. Okay, but they're a little bit different. Okay, they're similar, but they're a little bit different. So this is a guy called Charles Coulomb. This Charles Coulomb is a French physicist. Major contribution were in the area of electrostatics and magnetism. He also investigated in the area of the strength of the materials, structural mechanics, and some other called economics. Because he found called the Coulomb's law. The Coulomb's law, which is really important. Charles Coulomb measured the magnitude of electric forces between two small charged spheres. The force is inversely proportional to the square of the separation of r between the charges and directly along the line joining them. The force is proportional to the product of the charges Q1 and Q2 on the two particles. The electrical force between two stationary point charges is given by Coulomb's law. So, well, let me write this Coulomb's law in mathematically. Before we come to Coulomb's law mathematically, let me say something more about the Coulomb's law. Because in this law, we have some concept here, which is not easy to remember. Let me emphasize. The first one is called stationary point charges. What's stationary point charges? So this is really important concept. Stationary means the charge is not moving. Point charge means, well, it's sort of like an object. We abstract object as a point. Here we have a point charge. What's the point charge? The term point charge refers to a particle of zero size that carries an electric charge. So this is ideal. This is ideology, or this is only in an ideal situation, because in the real world there's no point charge. But because of there are so many objects are small enough, we can treat those objects with a certain charge as point charge. Okay. So electrical behavior of electrons and protons is well described by modeling them as point charges. Well, then the third one is the force is attractive if the charges are of positive sign. The force is repulsive if the charges are of like sign. The force is a conservative force, so be remember that. The force is conservative force. So written in the Coulomb's law in mathematically, and then basically this is the fourth between two charges equals to K, which is a proportional constant. And then this is Q1 times Q2 is the charge of Q1 and the charge of Q2, then divided by R squared. So this is inversely proportional to the distance between these two charges. Okay? And for this constant K, there are a number called 8.9876 times 10 to the 9th Newton's meter squared per Coulomb square. Well, this is something I assume you will be able to memorize during the exams. Okay. Well, it's very difficult to memorize this, but we will see. You will read more textbooks, and hopefully you will be able to memorize. Okay, and then this is also equal 1 divided by 4 pi epsilon 0. This epsilon 0 is called permittivity of free space. And there are also a number here. Let's have a break for 10 minutes. Let's have a break for 10 minutes. I'll come back. Hopefully, we will continue. Not hopefully, definitely, we will continue our lecture after 10 minutes break. Okay? Okay, see you in 10 minutes.